Carré Deniz Sahel Beldesi, which translates to Black Sea Coastal Resort, is a luxury resort-style hotel and mixed-use facility located on the European side of the Greater Istanbul region. Within the district of Arnavutköy, the design team selected a project site in the Black Sea coastal village of Karaburun, which is located approximately 15 miles north of the city of Arnavutköy and 1 hour northwest of Istanbul. With the opening of a new international airport 8 miles to the southeast, the small fishing village has recently been redefined as a developing tourist town. Within the village, the project site is situated on an existing greenfield corner lot formed by Lyman Road, the village's main connection to the Greater Arnavutköy district and Istanbul, and Sahil Road, the main coastal road, and contains an existing bus drop-off. The selected site was chosen due to its strong transportation connections, available renewable energy sources, and redevelopment opportunities. The Arnavutköy district is located in ASHRAE Climate Zone 3A, which reflects a warm, humid climate with an average temperature of 57.5 degrees Fahrenheit. The district has a summer high temperature of 75 degrees Fahrenheit, winter low temperature of 40 degrees Fahrenheit, and average annual rainfall of 28 inches. Using Climate Consultant to analyze the overall climate, the design team found that relative humidity ranges from 64 to 82%, and the temperature for most months fell below the human comfort level, thus requiring heating for most of the year. Wind primarily originates from the northeast, with a velocity ranging from 3 to 31 miles per hour.
Based on the topography of the selected site and adjacency requirements of program spaces, the design team determined that the base building required modifications to accommodate sustainable systems and additional program requirements of a resort-type hotel. The project was studied using Insight 360, a high-performance and sustainable building design analysis program. Insight 360 helped to determine optimal orientation, fenestration, and shading, as well as roof and wall construction. As previously mentioned, the project is sited at the intersection of two major roads. One leads inland to the new airport and city of Istanbul, while the other runs along the Black Sea coast. The building establishes a new center for the village of Karaburun and provides a gateway to the Black Sea. The site plan shows the horizontal and vertical circulation paths that intersect the project to integrate public and private circulation through the site. There are 3 exterior courtyards that intersect the building running in the north-south direction. Vertical and additional horizontal circulation runs east to west and allows pedestrians to manually ascend the site by promoting the use of stairs with direct views of the Black Sea. The orientation of the building allows each program space to capture views of the Black Sea while minimizing obstruction for surrounding structures as the building cascades down the site. The existing bus loop was redirected to maneuver the topography, with the entrance located at the west end of the site, moving along the southern perimeter, exiting at the east onto Sahil Road and creating a drop-off with direct access to the public courtyard's hotel lobby and restaurant. The modularity of program spaces allows each level to have unobstructed views of the Black Sea. There are 3 horizontal courtyards that step up the site, aligning with the existing pedestrian path on Lyman Road. The western end of the site features a Venturi wind tower that generates 90% of electricity for the building and incorporates a curved pedestrian ramp that allows pedestrians to experience the technology in detail. Level 1 contains retail, restaurant, and hotel public spaces arranged around an open courtyard, shown in green. Level 2 contains the hotel recreational spaces, featuring the pool and thermal baths that overlook the Black Sea on the eastern end of the site. Hotel guest room modules are adjoined to the recreational space by the public courtyard that divides the 2 modules and provides connection to the upper and lower levels. The circulation space on each level is continuous around the outer edges of the module, allowing fluid transition from east to west and north to south. Level 3 is continuation of hotel guest modules that rise with the site to connect with the office and parking module. Level 4 and 5 consist of the office, which was positioned at the western side of the site and is adjoined to the Venturi wind tower. The primary goal for building enclosure was to implement a low-tech assemblage that functions and performs as a highly sustainable building. Readily available materials were of high importance to the project team. The modularity of the design allows for a minimal number of wall types repeated throughout the project. The Tula wall construction was arranged as a structural and non-structural element separated by insulation and moisture barrier. The inverted umbrella roof system joins with the low-E clear-story window at the roof edge. Interior insulation in a continuous moisture barrier at the roof provides a continuous line of enclosure between the roof and the length of the wall. The gabion wall section allows a minimal width gabion basket to provide texture to the facade while supporting and anchoring to a structural Tula wall.
The design team utilized Insight 360's lighting analysis to determine the project's solar illumination as compared with the original baseline building. The results showed a 25% improvement by increasing from 60% of the spaces in the original footprint to 75% in the redesigned layout. Inspired by the designs of Felix Candela, hyperbolic paraboloid roof shells with integrated glass block penetrations were used as part of the daylighting strategy while creating a unique lighting experience for the visitors to the resort. The glass blocks were arranged in conjunction with photovoltaic and solar thermal roof panels to create an integrated daylighting and power generation strategy. In addition, the luminance renderings through Revit informed the design team that the daylighting system fully satisfied ASHRAE standard 189.1. The project's electric lighting was designed in coordination with the daylighting system to ensure optimal lighting performance. Automatic lighting controls, HVAC controls, and occupancy sensors were selected to further increase the overall efficiency of the electrical system while improving the indoor environmental quality. The design team used AGI 32 to analyze the electrical lighting performance and ensure the proper illumination levels were achieved. The ability to meter individual spaces via the distribution panels in the building program was important in order to track the energy usage for the various space types. Control monitors, located in open terraces for the public, display in real time the energy savings of the building. A single-ended substation with a 750 kVA transformer was used. Sustainable energy sources in the building promote hotel tourism and ensure guest comfort through uninterrupted power. The 3 sustainable energy generation systems designed include a wind tower, roof-mounted PV, and solar thermal panels. A total of 1,260 PV panels are used in the design to create a 445 kilowatt PV system. Offset distances from the roof shading zones were determined with a solar study in Revit for the month of December. Making the panels flat compensates the increase in the initial first cost with an increase in the payoff period, while maximizing the amount of PV panels that can be placed on the roof. Wind power generation was chosen because there are many wind turbines near the Black Sea region already, with a median wind speed for the site at 14 miles per hour. A precedent for the design came from the Involux product of the company Shearwind, which has built several operating Venturi wind funnel turbine systems. Located at the highest location on the site, the wind tower utilizes the Venturi effect to harvest more power. Omnidirectional intake of a Venturi wind funnel tower allows wind to enter in any direction with a cut-in wind speed of 2 miles per hour, while the outflow enters into the ventilated parking garage via metal grate floor drains. 3 9-foot diameter gearless wind turbines are located in the increased air velocity region, producing over 3.3 million kilowatt hours annually, or 90% of the building's annual energy needs. Electric vehicle charging stations are provided to office tenants and hotel visitors in the parking garage. The charging stations will be used to allow shared drivers and additional transport services to operate in conjunction with the existing bus system and to provide transport to the nearby newly constructed airport. Vanadium redox flow batteries are used as a power backup system to sustain critical loads for a duration of 1 day off-grid and to utilize peak shaving from the utility. Timed controls will allow the generator to start after the flow batteries are at critically low levels to provide an uninterrupted power supply in the event of an emergency.
The design team selected a flat-plate solar thermal system to heat the large amount of hot water needed for the mixed-use program. The system employs 32 panels mounted on the roof to heat domestic water before transferring to a hot water storage cistern and used through the hotel, restaurant, and retail spaces. The geometry of the inverted umbrella structural roof shells allows them to act as natural rainwater collectors. With a large roof area and 28 inches of annual rainfall, approximately 720,000 gallons of water are collected per year to reduce the overall potable water consumption. The collected rainwater is transferred through the structural columns to storage cisterns located at the eastern end of the site, near the resort's main entrance from the Black Sea. These cisterns are comprised of 2 rainwater cisterns and 4 potable water cisterns, and were sized based on the potable water demand to hold approximately 1/3 of annual demand. To treat the rainwater to potable water, it passes through ceramic filters, UV treatment, and a clarifier with chlorine. The chlorine is added to reduce bacteria growth while the potable water is in storage. Activated charcoal fixture heads were selected to remove the chlorine prior to occupant consumption. Gray and black water were collected from the site to be treated to reusable gray water through a living machine. The living machine is a natural water filtration and purification system through wetland ecology. 125 gallons of collected gray and black water can be treated each hour through the living machine. Once the rainwater is treated to potable water, it is used for sinks, showers, and dishwashers. The gray and black water that has been treated to reusable gray water is used for toilets, laundry washers, and site irrigation. To satisfy the Energy Policy Act of 1992, as well as the owner's request for a 30% reduction in potable water consumption, low-flow fixtures were selected, which resulted in an overall consumption reduction of 33%. The primary heating and cooling system selected by the design team is an open-loop surface water source heat pump. The system uses the Black Sea as its heat source and sink for the water-to-water heat pump system located in the mechanical room. Using the constant Black Sea temperature of 50 degrees Fahrenheit at 50 feet below the water's surface, the system supplies heating hot water at 130 degrees Fahrenheit and chilled water at 40 degrees Fahrenheit. Within the office, retail, and restaurant spaces, a radiant floor system is used to provide heating and cooling. The system consists of flexible tubing located in the concrete floor slab that is laid out in a counterflow design to ensure equal temperature distribution and provides comfort, heating, and cooling to the occupied air zone. The system ensures excellent indoor air quality without ductwork, circulating air, and other contaminants. 4-pipe fan coils are implemented in each hotel guest room. These units allow for simultaneous heating and cooling between rooms, thus giving each room the personal comfort control desired by occupants. The design team selected airflow panels as the main building ventilation system. Airflow panels are innovative individual energy recovery units that are integrated with the facade of the building. The polymer-based membrane with desiccant permeates moisture and heat between incoming and outgoing air. The use of these panels replaces the need for larger HVAC equipment and distribution ductwork. As a result, each space is supplied the outdoor air requirement of ASHRAE 62.1.
In addition to meeting ASHRAE Standard 189.1, the design team utilized both the U.S. Green Building Council's LEED version 4 rating system and the International Living Future Institute's Living Building Challenge 3.1 imperatives to achieve a fully sustainable and energy-efficient design. To ensure compliance with the ASHRAE, LEED, and LBC standards, the design team created a compliance matrix for efficient comparison. As part of the LBC imperatives, the resort was designed to be both net positive energy and net positive water. In addition, the proposed self-sufficient design provides significant cost savings over 50 years when compared with the original baseline design. To address daylighting concerns, the design team selected a combination of clear-story windows, glass block roof penetrations, and open courtyards to achieve the desired daylighting levels. The selection of locally sourced stone, concrete, and tula as primary materials align with the guidelines of all three standards. As a result of the integrated design process, the resort design satisfies all three standards, including achieving LEED Platinum certification and the Living Building Challenge Certified Living.
Through the integrated use of hyperbolic paraboloid roof shells for structural support and rainwater collection, a living machine for natural water treatment, and photovoltaic and wind power for net positive energy, the design team was able to produce a fully sustainable project that embraces technological advancements while honoring the rich history of the Turkish region. The resulting design provides unique experiential qualities in each program space and for all visitors to Karadeniz Sahil Beldesi.